Lesson 3.3. It's a little harder than the other lesson. So you really want to focus. If you want to sit closer, you can come sit on the floor if you're in the back.
Can we do that?
I don't mind. Really, I don't. Okay, so the other thing is you could always, I'm wondering if you needed like a worksheet. If you went to the YouTube, once it got to a completed step, you could print the screen.
Really?
I think so. So does that make sense? Like if you want a little like worksheet, like a little note sheet in your binder of samples. We ready? Then you could always stop, do a pause on the YouTube and print the screen. And then you kind of have like what it looks like. Okay, so we're constructing a perpendicular. These are the things we're going to do today. There's a few of them. The first one's constructing a perpendicular line through a point that's on the line. So this is, you're going to construct line CA perpendicular to AB. So if I were going to sketch it out, freehand, I basically want a line that makes a right angle here, and that's A, so I would have to label this point C. Does that make sense? That's the idea. No, I just did a sketch. That doesn't count. But when you do constructions, it's important to think about what it's going to look like before you start. Okay, just want to show you something else. The next one says construct a perpendicular line through a point not on the line. So you want to make PQ perpendicular to AB, but it's got to go perpendicular, so it would be like this. So you have to make the line go through P. And then you would label this point what?
Q.
Q. So they look sort of the same in the end, but they're different because the difference is the first one, the point is on the line. Point A was on the line. And the second one, the point's not on the line. It's off the line. Point P is off the line. Those are your reference points. Does that make sense? So this isn't a really good time to leave right now, Benji.
Oh, I was just going to get my compass. I could.
We don't need it right now. Just watch. Okay. So to the directions. Yeah. So do you remember the other day we did perpendicular bisectors? You guys got good at those in homework? So when you read this, and you know that your new line has to go through point A, what that should make you think is that you need to start at A. And what you're going to do is you're going to make a circle around A. And it doesn't matter how big the circle is, but remember, tiny little things, there's more error. So on the other hand, you want to make sure your circle doesn't go off the line, and if it does, you would just have to extend it. So I'm going to make a circle, and the reason that is going to help me is now, let's just call this point X and Y. I could make a perpendicular of X, Y, and it would go right through what? A. Does that make sense? So I'm going to put my compass. Remember, every time you do a construction, you use your new intersection point. So my new intersection points are X and Y. So I'm going to have to go beyond halfway to get the perpendicular bisector of XY. And so I just make either part or all of a circle. Abby? Sorry. Are we good so far? Now I'm going to pick my compass up and do the exact same thing with the same setting over here. So, that's okay. Your circles don't move like mine did. So the steps that I did was, first I made a circle around A. Construct circle A. and then, label X and Y. And then the third thing is construct the perpendicular bisector, which is last week's work, of segment X, Y. So there are your steps. Okay? Leah. I'm not, so now I'm gonna finish. So I'm writing my steps down while people process what I did. And then I'm gonna take a straight edge, and remember how this ruler is a little fussy on certain angles, it just doesn't always move the way I like it to, but let's see if I can get it to. Oh, that was shocking. So, sorry, and then I'll help you. So you draw a line through your intersection points, and then you have to label it, so you can put your point C anywhere. So then your step 4 is with the ruler, right? Or with a straight edge, draw CA. And it could be a segment. These could be segments. That's what they should say, segments. Paul, then Jack.
So the reason you construct the circle around A was to get points X and Y, so you can do the circle bisector.
Perfect. The reason I construct circle A is to get 2 points equidistant from A, and I labeled them X and Y, because then I can use my skill from last week of making a perpendicular bisector of a segment.
And I'm guessing you might not have to do that with the ones that aren't on.
I have to do it a little bit different with the second one. Abby, Jack?
Still don't, so why do you have to go to circle again?
Because I needed to find an equal, I'm creating a segment about A with
That makes
where X, A, and Y, A are the same distance apart. So when I do the perpendicular bisector of X, Y, it's gonna go through A.
XY isn't technically, you don't, like, you have to do it obviously, but it's.
You don't have to label them X, Y.
Right.
I'm labeling X, Y so I can talk to you about it.
Yeah.
So,
You can label it JC for J. Carew.
just take points are the X and Y.
Abby, what?
What points are the X and Y?
Right here is X, right here is Y. Jack?
I don't seem like, it's like kind of stupid, but like, why can't you just draw a line through it and then put a 90-degree?
Yeah, because you're using it, it's a construction. So,
But
turns out, you guys, let's go there. Actually, if you were gonna write a CAD program, like a program to do different design, it's all based off of circles. And because a compass basically makes circles, and with circles, you can do all kinds of constructions. And when you measure, it's a different skill, that's all. So,
we have to do it.
yeah, you could actually do all of this with a piece of string.
What?
Yeah.
Do we have to?
No, you could actually do all of this with a paper clip,
Oh, yeah,
with
you have
one
more-
radius, right? So,
You have more than one piece of string now, because it would be like, you have to.
just different lengths. But the point is, of course, you could draw this with a ruler and a protractor, but there's no thinking involved. So this is actually a really way to challenge your brain kinesthetically and mathematically at the same time. But this is something that's actually used in design. So we're gonna move on to the next one. So the next one is similar.
Oh, we're gonna do the same thing.
I gotta grab my compass. The next one's similar, but it's not exactly the same. Okay, because okay, now we're constructing PQ, so we have to find Q. And it has to be perpendicular to AB, and we have AB. Can you see that back there, you guys? Is that better? Okay. So remember, So this one, basically your first step is gonna place your compass at P. And
Sharp one, like pointy.
that point P is really big, so you can see it. But usually you'd see a nice small point because there's a lot of error. I could put the compass all kinds of places, but really it should just be a very small point. Benji. No. So the next thing is you're going to take your compass and open it so it falls below the line. Just has to fall below. So like when I rotate it, it's going to hit the line twice. You get that? So when you do that, then let's call these points X and Y again. So my first step was to make an arc or a circle, right? Make a circle P, because technically that blue arc is part of circle P. Does that make sense?
Yeah.
But what has to happen, it has to intersect line AB, and then you label the intersection points yes. Can I just say 2x? So for 3, now what am I going to do? Yeah, Connor.
So aren't you gonna take another, wait, never mind.
Lily.
You're gonna take the compass and put the point on X, Y, and
Right. We always use our new points of intersection,
make it larger than.
and we're going to do the same thing we did on the last one. We're going to go beyond the halfway point of X, Y, and I'm there. And I'm going to go and do the same thing I did above. And again, I've got those big points so you can see X and Y. You always use your intersection points.
Oh,
That's the whole reason we make arcs, is to get intersections, and then we use our intersections. So then we're going to take our straight edge,
oh, I get it. It's like I'm
and it should go right through P. It's pretty good. And then draw your line. And so this has to be, well, that's where you could put Q. So step 3 was construct the perpendicular bisector again, right? Of XY. So this is the symbol, perpendicular bisector of segment XY. And then step 4, you draw in, right? P, Q. You have to label Q. Leah.
with the half circles, half P or
The half circle, the half circle was centered at P, Leah. The blue?
yeah.
No, it can't. The purple, it doesn't have to touch P. It could, it doesn't have to. So then, one of the reasons we do this construction is so we can find the shortest distance from a point to a line. Because, as you guys probably could tell, there's lots of different ways to get from P to the line AB. Oops, that's supposed to be a straight line. So, but we're interested in there's tons of different paths from P to the line AB, but the shortest path is the perpendicular.
Yeah.
And you know that intuitively, and that is a conjecture in your book. It's along the perpendicular.
So the perpendicular is the shortest, the perpendicular line is the shortest line that connects to the other line, sort of.
So the shortest distance from a point
The perpendicular.
to a line is along the perpendicular.
Wait, not the perpendicular.
That's cool.
On along the perpendicular to the line.
It must have been so cool to
There-
write that
the
out the
perpendic-
first time.
That's what Euclid did.
He must have been like, yes!
And these are
These
called collapsible compass constructions. I erased too much. Yeah, because they're kind of some of the classic constructions. You do it with a piece of string. That's the collapsible.
I bet when you could.
But you don't want.
You don't want to.
Wait, are we going to have to?
I'll show that some other
You're
time.
gonna do an activity on
It's actually kind of interesting to see how you can do it.
How long until we do another investigation?
Yeah, you're going to be doing more in classwork after we get through the lessons. So starting with, what did I say, Thursday or Wednesday, we'll start be doing problem solving with this, where it's more in class. Okay, so next thing. I'm not going to do all three of these. Kira, I really am asking you to watch, because then it's easier to read your book. Okay, I would close the book up. One thing you have to do is construct altitudes, okay, in your homework. And altitudes are perpendicular segments from a point to a line. So, in other words, if you look at the bottom of this page, this down here is how you construct an altitude. No, this is all 3-3. 3-4 is super easy. It's just make an angle bisector. You can probably look at the picture and do it. Constructing altitudes is harder, so I'm picking to do the harder things while you're here. So if I wanted to make an altitude from B in the triangle on the right, from B to the base of the triangle, it has to be at a right angle. Right? You guys know that? And altitude's the height?
Right.
Okay. So it's what we just did, but here's the thing. When you look at the triangle, imagine that you remember from last year finding area. You always have to use the height outside the triangle, right? So you're going to be making an altitude outside the triangle. Does that make sense? If it's obtuse. If it's not obtuse, you would make the altitude inside the triangle. Got it? And there's 3, and they get pretty hard to see. Like this one would be out here. Do you see that? Because a height. Altitude is the height. Because I'll show you guys. Hold on. If I extend the base of this triangle, the height has to make a right angle with it.
What about that one in the middle?
Okay. Well, this one? Well, that's the base of the triangle's here. So the altitude just goes from a vertex to the base at a right angle. I'm just like sketching it, right? And the third base, maybe it would be better to do a little color coding here.
Yep.
So that altitude goes with that base. The yellow altitude goes with the yellow base. And then if I did a third one, green. So this base, does that help better?
Yeah.
So this base goes with the altitude that would be out here. You get that?
How do you know
But would it
that's
be
exactly
faster?
It's not exactly 90 degrees because I'm sketching it, which is why you're going to use a compass.
Oh,
It's like I planted you in the classroom to ask the question, Connor.
So like,
that's awesome.
the bottom one wouldn't be faster to like do the yellow line,
The yellow line is not an altitude. You guys, the triangle is right here. Altitudes sometimes are outside of the triangle when they're obtuse. Okay. Then all the altitudes are inside if it's acute. I'm just trying to find the altitude.
All you're trying to do. So,
Okay, so stop, look and listen. I just wanted you to get a visual of what an altitude is. Height of the triangle. Okay?
Do we need to know that for the section?
Yes, you have to be able to do the altitudes. I'm going to show you. But it helps if you know what I'm going to do before I do it.
Oh.
So maybe if I clone the page, you know, we can like get rid of some of this stuff. And I want to make an altitude. So the first step that you have to do to make an altitude of an obtuse triangle is you have to extend the base. So extend AT with a straight edge. That's the extend. I'm going to make the altitude BG. It's outside the triangle because it's the shortest distance from B to the line that contains the base of the triangle. So my first thing is just to extend the base in yellow. Done, right?
Hold it.
No, I'm asking you not to follow along. Abby, you're going to watch. Otherwise, we'll never get through anything. Okay, that's how we end up with not making any progress.
Oh, are we gonna start bringing in circles?
Okay, so now I'm going to make a perpendicular from a point to a line when the point is not on the line. So I do the same steps I did on the last construction. I have to go below the line and make an arc. So I'm doing the exact same thing. It's the exact same thing. My second step is to make circle B, right? But I just didn't draw the whole circle.
yeah, the D.
I'm having problems with my T's today. I forgot the T on the last word
Oh, did
too.
we mark the two different lines?
Now, yeah, and label the intersection. Oops. How about X and Y? Kind of boring, but maybe you'll see a pattern, right? X, Y.
C and D.
I'm seeing some patterns.
So what's the next step, Jack?
You take, so you go with put your X.
My compass on X.
And you have to go more than halfway.
Go beyond the halfway point of X, Y.
Arc. Your circle.
You can make a circle.
You can make a circle, but arc. Yes, do that.
I'm making the perpendicular bisector, that's right, Abby,
You do the same.
of X, Y. Should seem a little repetitive now.
It is.
There we go.
And so when I take my straight edge, I'm just going to use a straight line, but you guys are going to use your ruler. Oops, wrong place. I have to, yeah, better get the ruler. I gotta line my ruler up, or my straight edge, with the intersection points, but it should also go through B. And it's pretty close. This ruler's not gonna snap, I can tell. It's not gonna, I can't get it. Okay, pretty good. So, there's the altitude. And so this then is my point
So they're just trying to make
G.
like a right roll.
That's what an altitude is. It's a perpendicular from a vertex to the line, which is this yellow line, containing the base.
So like it'll always be the right.
If you make a right angle with the construction, Okay? Okay, so if I wanted to do a second altitude, I would just put my compass and construct circle A instead. Or, you know what I mean? Construct circle A. You do the same thing from any vertex. So my step 3 was construct a perpendicular bisector of XY again. And then step 4 is draw BG.
So, what is this doing for you? Like, did you find, what is it?
We just found the altitude, that's all it's doing right now. It's a skill. These are all just skills right now. It's not doing anything but teaching you skills. Then you use the skills to solve problems.
Okay.
Okay, okay.